Hello, good evening my 11th standard warriors. Today's session is all about phasors and how do you combine phasors or rather SHMs. And this will be useful to you not just in today's chapter but also this is having very good relations and it will lay the foundations for the chapters ahead. You will see that the concept of circular motion is very much related to simple harmonic motion, and simple harmonic motion is related to phasors, and you will see SHM. So when combined together, they are very much related to waves, which is also one of the chapters, not just in 11th but also in 12th. So that's what we're going to do today, and these are the things that I have planned for you. Simple harmonic motion as projection of uniform circular motion, phasor diagram, phase difference, combining SHMs in 1D and combining SHMs in 2D. So this is a part of Nurture series. Welcome aboard. This is Shreyas here, your physics master teacher at Vedantu, and I'm going live. Hi Speed Roshni, welcome aboard. Hi Ankit, hello Harita, hello, nice to see all of your hearts. Hi Abhishek. MBCR7, that's a nice code name you have. Hi Chandan, my day is very good. Hi Ganesh, welcome aboard. Thank you for the warm welcome you all give. So K Ramesh, the JEE crash course is in English. Okay, it's an English batch bacha. So go with it. It's just meant for you. All right. So welcome aboard. And thank you for liking the video and thank you for making our channel grow to more than 78,000 subscribers. And please do not forget to smash the subscribe button in case you haven't done it yet. And yes, do not forget to also recommend this channel, and you can do your bit by smashing the like button down there. So let's do a quick recap of what we have done till now. I'm also going to show you all the names who have done the homework as well. Yep. Yes, Prema Tiwari, let me tell you, I have already checked your mail and the mail has already been forwarded and you will get a call tomorrow. Yeah, it's already been taken care of. I have taken care of it. Don't worry. Yes, don't worry. All right, Ramya, hi, welcome aboard. So what and all we have done till now? Definitely, Ramya, I'll consider that. I will definitely do it. I know you have told this before, but yeah, just give me some time. I'll do it. Okay. Yeah. So energy of SHM we have done. So potential energy is given by a quadratic equation which is half k x square. K is your spring constant, and then if you write it in function of time, you can write it as sine square function by substituting x as a sine omega t plus phi. Then the kinetic energy is a cosine square function. I have told you this before. So if potential is sine square, kinetic is cosine square, and when you add them together you get the total energy as half k a square. If you are wondering why this m omega square has come, remember k is actually equal to m omega square because omega is root k over m. Okay, I have derived those things in the previous classes. So we have also seen the time period of a spring mass system which was 2 pi under root m by k, and we have also seen this result. Omega is root k over m, which is the angular frequency, and it is nothing but 2 pi f, or also 2 pi by time period. We have also seen when you connect springs in series, you can find the equivalent spring constant by just finding the constant, assuming they are like resistors in parallel. So the formula which you use for resistors in parallel is applicable for springs in series. And when springs are in parallel, then you just add those spring constants. Basically, you are treating them like resistors in series. That's what we have done till now. Now, let me also remind you, all the PDFs, all the things that I show you over here are also available on our Telegram channel, which is there. The link is there in the description box. So do not forget to join the Telegram channel as well. Not only for PDFs, but also the daily updates, reminders, and so many other things. Let's go ahead. Good evening, Murgesh. Hi, Uday, Zadav. Welcome aboard. Now, I have a question for you. Okay. So, in uniform circular motion, a particle, we all know a particle goes around like this with a constant speed. Fair enough. Now, do you know what projection is? What is the meaning of projection of anything? Well, Some of you might have heard this word, projection of this body on this. The meaning of projection is shadow, in simple terms, when light rays fall parallelly. So just imagine, this is the board, the light is towards you. Imagine I'm holding a particle here. Just imagine I'm holding a point particle here, this red cap of the pen. If light rays come from you, it falls on this object, the shadow will fall here, just behind on the board. Correct? Fair enough. Now imagine this particle is going in a circular path. Imagine this particle is going in a circular path. The rays are coming from where you are seeing me, from where you are seeing the board. So if this particle goes in a circular path, quickly answer, how will the shadow of this look like? How will the projection as in shadow, how will the shadow of this pen on the board look like? What kind of motion do you think it will, undergo? Can you just name it quickly? So if the particle, this pen's cap, is going in uniform circular motion, then on the board, what kind of motion do you think the shadow will undergo? Think about it. Yes, Uday says circular. Perfecto. Yes, the shadow will also go exactly like this. So you can see this is the shadow. Just imagine that is the shadow and this is the particle. That's it. So that is how it's going to go. That's all. Fair enough. Now I'll just do a small change. Okay, perfect. You are all right. Bingo. Very good. Kudos. Imagine now, instead of going like this, the rays are still coming towards me. I make the particle go like this. So to make you visualize that, I want you to visualize this as well. If the pen is here, the shadow will fall here. If the pen is here, still the shadow will fall there. If the pen is here, still the shadow will fall there. So the depth does not affect the shadow. The depth has no effect on the shadow. But if I move the pen here or here or there or here, the shadow moves. But if I move it here, no effect. If I move it up, yes. Down, yes. Left, right, yes. But like this, there is no effect on the shadow. Everybody agrees to this. So now take this as a hint and figure out how will the shadow look like if the pen moves like this. It's going in a circular path this way. It's going like this. Now try to visualize how will the shadow look like. Remember, the depth has no effect. Left and right, well, there is no motion. Up and down, yes, there is motion. So, yep, Uday says straight line, 1D motion. Straight line, 1D motion. Yes, Vivek, you have probably missed a couple of minutes. You can definitely catch up. Straight line motion. Perfect. Very good. You guys are superb. Yeah, superb. Perfect. Very good. Now, that 1D motion is also very peculiar. It's not any 1D motion. Yes, it's a straight line motion. Very good. So just imagine, I'll just hold my finger, just assume it to be the shadow, okay? And this pen goes like this. So it goes like that, it goes like this. It goes like this, it goes like that. Now just visualize. Can you visualize what is my hand, basically my shadow, what is my projection actually doing? The projection of this pen, what do you think it is actually doing? Yes, it's 1D motion, it's a linear motion, it's 1D translation motion, but it's a very peculiar 1D translation motion. It is basically oscillating. It is nothing but oscillating, and it looks to me like a simple harmonic motion. Yes, yes, it's repeating again and again, to and fro motion, oscillating. That's what it is doing. Beautiful. Look at this simulation now. You will get it. This particle is doing circular motion. This is doing circular motion. This is doing simple harmonic motion. This dotted line helps me calculate the shadow. So if the light rays are coming from there, if the shadow falls on this wall, you can see the shadow goes just up and down. Up and down. It is oscillating. This is performing uniform circular motion. Everybody is convinced with this. Perfect. Now, that's the reason why there are so many similarities between SHM and uniform circular motion. And I would always advise students to have a grip on uniform circular motion when you are studying SHM. And only when you study SHM you can understand waves, you can understand light waves, sound waves, and so many other things. Yep. Now we are going to make use of circular motion. What is the agenda of today's class? We are going to make use of circular motion to solve SHM problems in a simpler way. If you don't attend today's class, you will see by the end of it, you would have missed so much. And you will be like, oh my God, I can solve the question in such an easy manner using circular motion. I'm pretty sure you don't want to miss any of the problems and the theory that I'm going to do till the end of the class. So watch it carefully. So one thing is very obvious now. One thing is very obvious. Guys, this circular motion will have angular speed. I'll repeat. This circular motion will have angular speed. Whereas the SHM, it does not have angular speed because it is not having any angle. It has something called as angular frequency. It has something called as angular frequency. Now, I want you to quickly tell me if in circular motion, okay, I'll just put it over here. Okay, in circular motion, the time period of basically revolution, the time period of revolution is t, omega is the angular speed, then you all agree that time period is 2 pi by omega. This omega is nothing but angular speed. Now, haven't you seen the same relationship over here? Haven't you seen the same relationship in SHM? But the only difference is in SHM we call it differently. In SHM, you don't call it time period of revolution. You call it time period of, so you just call it time period, okay, of oscillation. You just call it time period of oscillation. And this omega, you don't call it angular speed. You just call it angular frequency. So here is what I want you to visualize. If by chance I tell you there is a SHM, there is a simple harmonic motion whose omega, let's say, is 4 pi radians per second. You should immediately think of a circular motion whose angular speed is 4 pi radians per second. You should immediately think of a circular motion whose angular speed is 4 pi radians per second. 4 pi radians means 2 revolutions. 2 pi, 2 pi, 2 revolutions. So it is doing 2 revolutions in 1 second. That's what you should think of it like. Are you now getting the feel of what actual angular frequency is? Everybody with me? Cool? Everybody able to understand what angular frequency is? If you visualize a corresponding circular motion, then you can always think of a circular motion whose angular speed is the angular frequency. Perfecto. Perfecto, Cholan. Perfecto, Uday. Very good. Vanakkam Zayad. Very good, Chandan. Perfect, Yoganand. Very good, Roshni. Now, there is more to it. There is more to it. And I'll show you what is more. Just let's rewind this simulation. This circular motion has a radius of circle. This circular motion has the radius, this line which is rotating. This simple harmonic motion has amplitude. Can you quickly write in the chat box? Let's see who is quick in this. Let's do quickly in the chat box. How many of you can find the relationship between the radius and the amplitude of SHM? Quickly put it up. Amplitude is twice the radius, amplitude is half the radius, amplitude is 10 times the radius, amplitude is not equal to radius. Whatever you feel, just put it up in the chat box. Think closely. The radius of circular motion and the amplitude of oscillation. Go on, quickly. Cholan says radius is equal to what? Okay, but you need to put it up, Cholan. Radius is equal to what? Twice says Ankit. Uday says equal, amplitude equals to radius says Cholan. Okay, Roshni also says equal to. Perfecto. You can see that. You can see that. How? This is mean position. This is extreme position. This is also extreme position. This is amplitude. This is also amplitude. This is radius. This is also radius. Radius is equal to amplitude. Radius is equal to amplitude. You can see that very, very clearly. It is equal to Subiksha. Radius is actually equal to the amplitude. You can see that. So, if somebody tells you about SHM whose amplitude is, somebody tells you about an SHM whose amplitude is 3 centimeters, quickly you should think about a circular motion whose radius is 3 centimeters. If they tell you the SHM is having angular frequency of 7 pi radians per second, you should think of a circular motion whose angular speed is 7 pi radians per second. So you can clearly see they are all related to each other. Now the question comes of what about the other terms like phi, x or y and all these things. Let's come to that. So for that I have shown one particle. I just shown one particle, and this particle is going in a uniform circular path with angular speed omega. Okay, it's going with angular speed omega. We have seen that you can specify the location, the position of this particle in polar coordinates. Polar coordinates is nothing but you specify the distance from the center, that is the radius, and the angle. So if I ask you what is the coordinate in polar terms for this particle, you will be like, it's at a distance of radius and making certain angle, maybe 20 degrees, maybe 30 degrees. That's how you would specify. And this particle right now is over here. This is, let's say, the initial position, and I'm going to call at t is equal to 0 the initial position, okay, the initial position vector from this point to this point. Okay, the angle which it makes, I'm going to call it as phi. So what is phi? Phi is the initial angular position of that particle with respect to the x-axis. So phi is the initial angular position with respect to the x-axis. Obviously the particle won't stay there. It's going to move. It's going to go from here. So when it moves, it's going to change the position. But at the same time, let's also talk about the projection of it. This point's projection on the y-axis will be here. Just visualize this. If this point moves, the projection will also move. So if this blue point moves, the projection on the shadow on the y-axis is going to move, and observe that carefully. Look at that. The particle moved. This particle moved from here to here. Obviously the shadow is going to fall somewhere else. Now I want you to think about it. If it moves for some time, from here to here it takes, let's say, time t, it will cover some angle. And do you remember what is angle divided by time called as? Angle per unit time, that is called as angular speed, if you remember. So therefore what will be that angle? It will be omega into t. Agreed? So this is nothing but omega into t. Everybody is able to see this. So after some time, this angle, extra angle covered, is nothing but omega into t. Perfecto. Now the shadow will fall. The shadow will fall over here. This is the new point. This is where it is. This is where it is. Now if I ask you, what is that y coordinate? How much is the length of this y coordinate? What will your answer be? Well, it's very easy. Just drop a perpendicular here. You can see a beautiful right angle triangle. I'm just going to highlight that for you. This is that right angle triangle which I've just highlighted for you. You want to know what's the y coordinate, that height. So that y will be basically the hypotenuse into the sine of this angle, or basically the sine of this entire thing. Yeah, it's opposite that. If you are not able to visualize it, it's okay. I'll just write it like this. The sine of that entire angle is opposite side divided by hypotenuse. What is that angle? This one, phi plus omega t, or omega t plus phi, whatever you want to call it. Isn't that right? Omega t plus phi. Perfecto. Just move it around. Oh, but wait a minute. I already know what is this hypotenuse. Think, what is this hypotenuse? Hypotenuse is the radius, isn't it? Hypotenuse is the radius. And we already figured out the radius is nothing but the amplitude of the oscillation. Radius is nothing but equal to the amplitude of SHM. So just move that term over here and see what you get. You will get y is equal to a into sine of omega t plus phi. What is this? This is nothing but the equation of SHM. This is basically the proof. What is the proof? the projection of uniform circular motion is SHM. I just proved it to you. So the shadow of uniform circular motion is indeed a SHM, is what I have just proved. Perfecto. Now comes the next trick. Now you start understanding, acha, so this is what phi is, and this is what probably the significance of phi is, and you will start understanding all the other terms out here. So let's start talking about it. Okay, let me get rid of this. Probably let me bring some text over here. Okay, so we have just got y is equal to a sine omega t plus phi. We have seen that the particle initially was at point Q. The new position is point P after some time. The total angle which it makes with the x-axis was phi plus omega t. That's what we have done till now. Now, this is how you now start relating uniform circular motion with SHM. Observe this. I'll start writing it down. Radius. Okay, first I'll put it over here. In uniform circular motion, and this is basically SHM. So what are the different comparisons? In uniform circular motion we have radius. In simple harmonic motion we have amplitude. They are exactly equal to each other. In uniform circular motion we have angular speed. Here we have angular frequency. Symbol wise it is nothing but omega only. It's the same, omega. Great. In circular motion, the initial position, initial angular position, this thing in SHM, this phi in SHM, what do you call it? You call it the phase constant, correct? You call it the phase constant. Very, very important. Similarly, this entire angle phi plus omega t, this entire angle phi plus omega t is the current angular position, the net angular position. So the current angular position, what is it called in SHM? Now this is a new term. That is called as the phase of SHM. What is it called, my dear warriors? It's called as the phase of SHM. So that is what phase is. So if somebody asks you, what is the phase? All they are asking you is, what is phi plus omega t? That's it, nothing else. Phi plus omega t is the phase of the SHM. Now, if I ask you, what is the initial phase? Initial phase means put the value of time as 0. So this term vanishes, you get this. So that's why phase constant is also called as initial phase. It's the same thing. Understood this? Thank you, Subiksha. Are you understanding the comparison between circular motion and SHM now? Everybody getting it? Very, very important table. Radius, amplitude, angular speed, angular frequency, initial angular position, phase constant or initial phase angle. Current angular position, that's just the phase of the SHM. That's it. Perfecto. Very important tables, very important diagrams just for you. Now, just imagine this. Let me just probably remove this off. Okay. Okay. So, okay, maybe I'll just go in the next diagram and show this to you. Okay. So, this is another very interesting simulation just to show you how the phase works. Look at this. This particle, the black one, is going in a circular path. Okay. The red particle, you can see it's going up and down, the projection. If you draw the graph of the phase, look at it. The phase, if it starts from here, if the black particle starts from here, it slowly starts increasing the phase angle, and once it completes one revolution, so it covers a phase of 2 pi radians. So now it makes sense. Why? 2 pi radians is always associated with one complete oscillation. So one complete oscillation is how much phase, my dear warriors? One complete oscillation is how much phase? It is 2 pi radians. That's what you can see. Perfect. So this is again an interesting visualization. I just want, why am I showing you all these visualizations? I want you to think, because all this will come in waves, it will come in electromagnetic waves, light waves, everywhere, and I want you to get a feel of how SHM works and how it is related to waves as well. There's a beautiful simulation for that. Look at this. This is a spring mass system. It's going up and down. You have a paper rolling, and look at the beautiful wave which is created right over here. That's what I want you to see. Beautiful. It's very much related to waves. You will see the significance of this simulation in waves. I want you to get the feel of this. Okay. Now, what is phasor diagram? Let's come to that. What is this phasor diagram? See, a phasor diagram is a diagram which is derived from the circular motion using all the parameters of SHM, like omega, amplitude, phase, initial phase, everything. Is just a diagram, representative diagram, which is helpful for visualizing and solving problems. So a diagram which is directly dependent on your SHM, which is a physical thing. It is actually moving back and forth, up and down. This diagram helps me visualize that SHM. It is basically, whose shadow gives me that SHM. So you're trying to go reverse. Whose circular motion is this shadow? So looking at the shadow, you're trying to predict, go back and figuring out that circular motion. That is nothing but your phasor diagram. Yes, looks like a seismometer. Okay, will I be doing revision session for term 1 physics class 12? Yes, Rishabh. Like I mentioned, I'll be doing 3 marathon sessions just for you on 7th, 8th and 9th of December and 10th of December paper. So 4 sessions together. On 10th, I'll be doing discussion. Okay, now going back over here, let's see what we can do. All right. Now, if I show an arrow mark right over here, this is basically at time t is equal to t. Okay. This particle might be going this side. This entire angle is phi plus omega t. This height, like we know, is y, which is a sine omega t plus phi, and this is nothing but a. This diagram is called phasor diagram. This arrow mark which is rotating, okay, this arrow mark which is rotating, this is called as your phasor. This is called as your phasor. This thing over here, what is it called? I just told you. This is nothing but phase. So what is the length of the phasor? If somebody asks you, come on, quickly put it up in the chat box. What is the length of the phasor? The length of the phasor is nothing but the radius or the amplitude. That's it. That's a phasor diagram. The phase angle is nothing but the angle which the phasor makes with your x-axis or the reference axis. As simple as that. Now, if I ask you, just imagine how will the phasor look like for a particle, example, for a SHM, which starts from the mean and going to the extreme up, okay, going to the extreme side on the positive side. How will it look like? Try to visualize. So if I even try to draw a SHM, this is, let's say, mean, this is, let's say, positive extreme, this is the negative extreme. How will the phasor look like for a particle which starts from the mean and going towards the extreme? I think I know what it is going to look like. It is just going to be horizontal, because the shadow will be over here. The shadow will be over here. Do you guys agree with it? Yep, the shadow will be exactly on the horizontal axis. Now, if I ask you, what is the initial phase angle? This is at t is equal to 0. What is the initial phase angle? Won't it be 0 radians? Won't it be 0 radians? Hi, Lankesh. Everybody gets this? Very easy. So, a particle which starts at the origin, what is the initial phase angle? 0 radians. Perfect. What if the particle starts not from the mean, but if it starts from the positive extreme? If it starts from the positive extreme, then it just means one thing. My phasor will be here, so that the projection falls over here. My phasor will be here. That means at t is equal to 0, if your phasor is here, the initial phase angle is how much? 90 degrees. It is 90 degrees or pi by 2 radians. Same way, if I tell you the SHM starts from mean, but going to the negative extreme. Think, if you start from here, the projection will go towards positive extreme. If you come over here, then the shadow will still fall here. But when you go down, it will go towards the negative extreme. So basically, I am starting from, if I start from here, then my phi will be 180 degrees or pi radians. Exactly. Okay, it's not minus 270, be careful, it's 180 degrees. Okay, be careful about that. Yes. And if I tell you it starts from the negative extreme or the left side extreme or the down extreme, then my phasor would be here. This will be at t is equal to 0, and the phase angle, the entire angle will be 270 degrees. That's how it works. Got it, my warriors? Now is it making sense? So if I start from here, shadow is here, 0. Goes here, shadow is there, 90. It goes here, shadow is still here, but I'm going down, so the shadow will go down, so it's 180 degrees. I start from here, my shadow is also down, that's 270 degrees. As simple as that. Okay, perfect. So let me just one second. Okay. Yep, just 1 second, my warriors. Okay, perfect. Great. Now let's start doing some questions out of this, now that you have understood what is phasor diagram. Okay, and this is another, by the way, this is what you have to think. Every time you will have a real problem, you will have a virtual world in which you will have the phase space. You might have heard of this Metaverse which Mark Zuckerberg has created. I want to do a session on that. What about it? It will be fascinating, isn't it? Talking about what is Metaverse, what is this cyberspace, what is this new virtual reality, virtual space that is being talked about so much, and what is the scope on in the future? Does it have something to do with you probably in the long term? So this is your actual SHM, but this is your phase space. This is a different environment, but it is resembling this. It somehow resembles it. You can see that. Okay, let's do some questions. Perfect. The amplitude and the periodic time of SHM are 5 centimeters and 6 seconds respectively. At a distance of 2.5 centimeters away from the mean position, the phase will be. Come on, let's do this. Here's the first question coming up on your screen. Let's start doing it. And we have lots and lots of questions. The amplitude and the periodic time of a SHM are given. Okay, so let's start with a phasor diagram, because that's what we have learned today, and you will see it will be very, very simple. Okay, so I know the amplitude is 5 centimeters, that means radius is 5 centimeters, time period is 6 seconds, okay, distance of 2.5 away from the mean position. So think about it, this is technically the mean position, 2.5 centimeters away, that means this much distance, so this is 2.5 centimeters. The question is, what is the phase? Okay, so if the particle is here, the shadow would be falling from somewhere here, let's say. So this is my phasor, you can see this. So this is technically my phasor. Hence, this complete thing is nothing but my phase angle, which has been asked. This is exactly what has been asked. This is 2.5 centimeter. The length of this phasor is 5 centimeter. So this is basically 5 centimeters. Now I think I know what to do next. Yes, Bhala, there is a crash course batch which has just started. You are still eligible to join the crash course batch for the 11th standard. It's just, even if you have missed the first starting point, don't worry. There is another batch which is just starting this Monday. So you can just get yourself enrolled in that. Okay? Yes, for 11th standard 2023 students. Now, can you see, if this is 5, this is 2.5, I think I can calculate this angle. Because if you notice, cos phi will be adjacent, which is 2.5 divided by 5, which is nothing but half. So therefore phi is nothing but how many degrees? It is 60 degrees. So if phi is 60 degrees, what will be the phase angle? So the phase angle will be 30 degrees, because the entire thing should be 90. So 30 degrees is nothing but pi by 6. That's option D. Done. Perfect, Cholan. Very good, very good. Yes, BN gamers, you are a little bit late, but you can join in. If you know a little bit about the topic, then yes, start solving the problems. But if you need some help, you can do one thing. Even in the live class, you can go a little bit behind and watch whatever you have missed at 2x speed as well. Okay, moving on to the next question. Perfecto. A particle executing SHM of amplitude 4, time period 4, the time taken by it to move from positive extreme to half the amplitude. Interesting question. Again, start with phasors. It will be very easy. If you try to do it with equations, you will get stuck. Today's entire solving is just via diagrams. Isn't it fascinating? No equations. Yep, true. All the equations, only diagrams say we are going to solve the questions. That's the best part of today's session. So again, draw the vertical line, draw the horizontal line, just for your reference. Amplitude is 4, radius is 4. From positive extreme to half the amplitude. Okay, what is the positive extreme? This point is basically your positive extreme position. From positive extreme, it has to go to half the amplitude. This is amplitude, right? This entire thing, the radius is amplitude. Half the amplitude means here. So if it has to go from here to half the amplitude, means the shadow should fall from here. That means the phasor must be somewhere over here. Do you guys agree with it? So it starts over here and it comes over here in some time t. See if this is understood. So this is basically half the amplitude. Half the amplitude. Perfect. Now observe carefully. What is the amplitude? Amplitude is 4. That means the length of this green line should be 4 centimeters. The length of this green line should be 4 centimeters. And think carefully, this one is half the amplitude. Half. That means this should be 2 centimeters. Perfect? Okay. That means I can find out how much this angle theta is. And I can use again, I think, cosine theta. Cos theta in this right angle triangle will be adjacent by hypotenuse, which is half. So theta is 60 degrees. Now I have a simple question for all of you. For this particle to go around the entire circle, it takes 4 seconds. So in 4 seconds, it covers 360 degrees. In t seconds, it covers 60 degrees. So the question is, how much is this t? Can you quickly tell me how much is this t? Is it not like a unitary method? For this much it is this much. So for this much, how much it is? 2 boxes cost this much. 5 boxes will cost how much? Very, very easy. Many of you are saying option C. Come on. 60 degrees is 1/6 of 360. So t will be basically 1/6 of 4 seconds, which is 2/3 seconds. And most of you are correct. Very good. Proud of you, my warriors. Did we do any complicated maths? Did we not make use of the diagrams? Do you see the benefit of learning phasor diagram? Can you see we have avoided so many complex equations? Else I would have to use x to a sine omega t plus phi, substitute the values, solve the trigonometric equations. It would be a mess which nobody wants to get into. Nobody wants to get their hands dirty out there, right? So that's how it is. 2/3 seconds. Perfecto. Moving on to the next question. Look at this. Again, what do we have over here? There is a particle which is executing SHM with a time period of t seconds. Amplitude is a meters. The shortest time it takes to reach a point which is a by root 2 from its mean position in seconds is how much? Let's try to do this. Again, start with Phasor diagram. It's going to make life easy. That's why you are attending today's class. So let's do this. Again, circular motion, again vertical and horizontal lines. Perfect. Okay, so the question is shortest time it takes to reach a point this much from the mean position. Where is the mean position? Mean position is over here. Mean position is over here. And a by root 2. Okay, the length of this is a. So a by root 2 will be somewhere over here. So this is basically, okay, I'll just mark it over here. This is nothing but a by root 2. Fair enough. So when you are at mean, think about it, the phasor will be here. When you are at mean, the phasor will be horizontal, the shadow will fall here, correct? The shadow will fall here. As you go up, the shadow moves up. As you go up, the shadow goes up, correct? So I think after some time, the phasor would have reached here. This is where it was at t is equal to 0. This is where it is now. It has covered some angle and that's why the shadow has fallen here. Perfect. Great. The length of this arrow mark is a because that's what the amplitude is. Okay, again look at this angle theta. Okay, I think I can find again cos theta. Let's see what we can do next. Cos theta is adjacent side, which is a by root 2 divided by a. That means it is 1 by root 2. That means theta is, how much is theta? Cos of whose is 1 by root 2. It is 45 degrees. It's 45 degrees. But that's not what I want. I want this angle. So the angle covered. So this angle, let's say, I don't know, I call it maybe psi or something. Okay. So what is psi then? Psi is again obviously 90 minus 45, which is also 45 degrees, which is basically angle displaced. Angle displaced. That's it. Now you have your job done. Many of you are saying option C. Looks like you are getting the hang of it. Again, use our technique. It takes t seconds, is it? Yeah, it takes t seconds to cover 360 degrees. So it takes small t seconds to cover 45 degrees. So how much is this t? Obviously, this t will be 45 into how much is 36? 90. 8 times, yes. So this is obviously t by 8. T by 8, which is option C. 1/8. 45 is 1/8 of 360. Perfect. I think you are getting the hang of it. Very good, Cholan. Very good, Vempadu. Chandan, excellent. Hi, Jairam. Welcome aboard. Hello, Maulish. Very good, Harita. You're quick in that. Very good, very good. So the answer is t by 8 seconds. Perfecto. Now, let's talk about something called as phase difference. What is phase difference? We just got to know what is phase. The difference of phases, simply put, is called phase difference. But, like phase difference between what? You need two things to find difference. So, when you have two SHMs, imagine one SHM is going like this, another SHM is also going like this. Each one of them will have circular motions associated with it. Each of the SHMs will have circular motions associated with it. The phasors will also be rotating. The phasors will also be rotating. I'll just give an example out here. So just imagine you have on this line this SHM, okay, and the phasor of this is, let's say, this one. So the shadow is falling here. Just an example. Okay, this is phasor number 1. You can draw the phasor shadow on X or Y. It really doesn't matter. This is phasor number 1. Let's say it is rotating like this. Let's say you have another phasor, okay, and another SHM. So let's say another particle is here. So the shadow of that, okay, might be here. Okay, so this is phasor number 2. Now if I bring both these arrow marks on the same diagram, maybe the red arrow mark comes here, maybe the black arrow mark comes over here. They could have different amplitudes, but they are both rotating, okay, like this. They are both rotating like this. Now, the difference of the angle between them. Can you see the difference of the angle between the phasors? This angular difference between the phasors is called as basically the phase difference. Phase difference. As simple as that. Now, If I ask you what is the phase of SHM1, so the phase of SHM1 will be omega t plus phi 1. If I ask you what is the phase of SHM2, it will be omega t plus phi 2. So hence, if I ask you what is the phase difference, if I ask you what is the phase difference, what will your answer be? This minus this, the whole angle minus this angle. Do you guys get it? Because if I talk about phase of 1, it is this entire angle. If I talk about phase of 2, it is this angle. So when I asking you this green angle, it will be this big angle minus the small angle. Can you see that? Everyone? All of you? Yeah. So omega t cancels. So what is remaining in the phase difference? It is just phi 1 minus phi 2. But I don't know who is bigger. So I'll just put modulus symbol. So whenever they ask you phase difference, you are generally asked the modulus of that. Okay? So it's just the mod value, whichever is bigger minus the smaller value. As simple as that. So that is what phase difference is all about. Phi 1 minus phi 2. Some books also use, for phase difference, they use the symbol del phi. It makes sense. Change in the phi. Difference of phi. That is also called as the phase difference. Perfect. You guys are understanding really well. Proud of you. So let's move ahead and solve some questions on phase difference. But before that, so for previous sessions we used cos. Well, no, in fact we use sine, but you can also use cos. It really doesn't matter. So let me tell you. See, some of you always ask this doubt, sir, should we use cos or should we use sine? Okay, here is a simple answer for this. If you draw the phasor, okay, and if this angle is omega t plus phi, okay, this is how it is moving, this is A. Now, if you draw the height, okay, this one, this will be y is equal to A sine omega t plus phi, because this is opposite to it. But if you look at the adjacent side, then what will it be? It will be x coordinate, which will be A cos omega t plus phi. So whether you use sine or whether you use cos, it is still a SHM. It is still a SHM. Just the way in which you are looking will change. Are you looking at the y coordinate or are you looking at the x coordinate? That's it. So it really doesn't matter. Okay, is that clear? Cool. So let's talk about two special cases which are very useful. One is called same phase or in phase. The second one is called out of phase. Look at these two spring mass systems. They both are moving in sync. They both are moving together. So what should I call them? I should call them same phase, or basically there is no phase difference, or basically they are in the same phase. So they are also called as in phase. In phase. You can see that they are just moving in phase. Okay? Cool. So the next thing that we have is opposite phase. Look at this, opposite phase. Opposite phase means when one is on the top, one is below. When this one comes down, this one goes on the top. So when you have opposite phase, then you will see both of them are just doing exactly opposite of each other. So in this situation, how will the phasor diagram look like? If the phasor for one is like this, the phasor for the other will be like this. The phase difference between them will be 180 degrees, or basically pi radians. This is phasor for 1, this is phasor for 2. Looking at, are you able to understand this? So this is what opposite phase looks like. So for in phase, the phase difference is 0. For out phase, the phase difference is pi radians or 180 degrees. As simple as that. Everybody getting it? Cool. Shall we proceed with some questions? Come on, my warriors, let's do this. Okay? Cool. Let's do this. Here is your first question. X is A sine omega t plus phi by 6. X prime, matlab some other SHM, is A cos omega t. Then what do you think is the phase difference between the two waves? What do you think is the phase difference between the two waves? Come on, let's try to figure this out. If you notice, X is just A sine omega t plus pi by 6. You might think, sir, this has just omega t, this has omega t plus pi by 6, so the phase difference is pi by 6, hence the answer is B. But let me warn you, this is sine, this is cosine, so you cannot just take the difference. Be very careful. So when you write x prime, it is A cos omega t, of course, but try to bring it in the same format. So how do you convert that? Remember this formula? Sine of theta plus pi by 2 is actually cos theta. Sine of theta plus pi by 2, second quadrant sine is positive, so it converts into cos. So if I use that, just use the reverse. So this will be nothing but sine of, omega t plus pi by 2. So this is what x prime is actually. Now you can clearly see this is also sine, this is also sine. Now you can compare them. So one has a phase of phi 1 of pi by 6, this has a phi 2 of pi by 2. So we can now find the difference. So delta phi will be pi by 2 minus pi by 6. Basically 90 minus 30, which is 60, which is nothing but pi by 3. So hence the correct answer is option A, not B. Yep, very good Chandan, very good Cholan. Perfecto. Yeah, a lot of students make that mistake and write it as pi by 6. But yes, that conversion was very important. Yeah, the option A is correct. Moving to the next question. Again, beautiful example of phasor diagram. Don't get scared by the length of the question, trust me. There are two particles which execute SHM, same amplitude, same frequency along the same straight line. So basically they are going like this, okay? They're just going along the same straight line. They pass one another, that means they cross one another, okay? When going in opposite directions, and each time they cross it, basically their displacement is half the amplitude. Their displacement is half the amplitude. Let's try to do this. Very good, Gokulnath. How was your term examination today? Alright, let's draw the phasor diagram. The horizontal line, the vertical line. What did I tell you? We are not going to do much of equations, it's more of diagrams today. They cross each other when the displacement is half the amplitude. So this is the amplitude, half the amplitude is over here. This point is basically half the amplitude. That's what this point represents. Now, if that's the case, this length will be A by 2. So, if there are two SHMs, there will be two phasors. One of them is going this way, another is going that way. So just think, if this is the shadow of two phasors, where would the two phasors be located such that the shadow comes over here? I think one though I can easily see right over here, this phasor going like this, the shadow is this one. So when this goes like that, so this point goes up, correct? When this phasor turns this way, you can see this point goes up. I think I can also imagine one more phasor over here, like this, but it's continuing like that only. So when this phasor turns like this point goes down. So these two phasors rotating are creating 2 points, one going up, one going down, basically crossing each other. Can you see that? No, Abhishek, trust me, it is not tough. Whoa, proud of you, Gokulnath. Proud of you. Very good. Keep it up, bacha. Keep it up. Very good. So basically these are the 2 points. Okay, they are going like this. So this guy's projection goes up, this guy's projection comes down. So you have two SHMs crossing each other exactly midway between the amplitude. Okay. Now the question is, what is the phase difference between them? It's very easy. I'll tell you what to do. Do you agree this angle and this angle both will be equal? Because these two are congruent right angle triangles. So can I call this angle, let's say, as phi, or I don't know, theta also? Both these angles will be the same angle. Perfect. Yes, Medico Vibes, definitely you can watch it. Now the length of the red vector is A, the length of the red vector is A, the length of the green vector is A by 2. You can see a right angle triangle. What is cos of phi, my dear warriors? It is adjacent, which is A by 2, by hypotenuse, which is A. A goes, this will become half. So phi, whose cos is half? It is 60 degree, correct my warriors? So we got phi as 60, but that's not what the question is. The question is, what is the phase difference? So what is the meaning of phase difference? It is this total angle. So this total angle is nothing but your phase difference. So if this is phi, this is phi. So can you quickly guess what is the phase difference? Shouldn't it be 2 times of 60 degree, which is 120 degree, which is option D? Is it done, done? Very good, Subiksha. Very good, Chandan. Very good, Roshni. Perfect. Do you appreciate that the fact that we have not used any SHM equations in solving any of the problems till now? That's the best part about it. Perfect. So 120 degrees. Now comes the story of Pandu and Champa, and this is going to be really interesting, so tune in. And if you guys are loving this session till now, yes, do not forget to smash the like button and also hit the subscribe button so that you do not miss any of the classes ahead in the Nurture series for 11th standard. So let's see what is Pandu and Champa doing. So we have a Pandu here, and what does he do? Well, he goes back and forth. Okay, he's just going to go like this, he's going to go like this, he's going to go like this, he's going to go like that. He's doing SHM. So I'll write it over here. XP is the equation of Pandu, and it is amplitude of Pandu sine omega p. Initial phase is 0. So he just keeps moving back and forth, back and forth. That's what he's doing. That's his job. Fair enough. Okay, so it just goes like this and goes like this. Now he carries something with him. He just carries something with him and he goes like this, left and right. He's doing this dance. I don't know. Is this some step in some movie? I don't know. Okay, so he just does like this. Okay, he just does like this. Oh my god. Guys, please don't make this a meme or a GIF. Okay, I'm warning you. Don't make this GIF. Okay, whatever I did just now, don't make any GIFs out of it and don't share it. It will be, I don't know, might be viral. Okay, so anyways, he's holding something and he's just doing like this. One more opportunity, but don't make the GIF. Okay, so now there is Champa standing on this platform. This is Champa. What is Champa doing? This is Champa. Okay, they just show her hair, beautiful hair, wearing a beautiful red lipstick. Okay, now this Champa goes left and right. As Champa also goes left and right. For now, ignore Pandu. Just Champa is standing on the platform. She is just doing a dance. Okay, just doing a dance like this. Okay, I'm not doing it as gracefully as Champa is doing, but yeah, whatever. XCP. This is position of Champa with respect to Pandu. She's on Pandu's head and she's just doing this. Okay, whatever. All right, cool. So this will be nothing but AC sine omega t, but there is this phi. Okay, if you're not understanding why this phi has come, maybe she's not in sync with Pandu. When Pandu does this, Champa does this. I don't know. When Pandu does this, maybe Champa also does this. So maybe there is a phase difference between them. So this phi represents the phase difference. Pandu and Champa cannot or may not be in sync between Pandu and Champa. Perfecto. Now what's happening is, let's combine both their motions together. Let's see what will happen if both do this dance together. How will the actual motion of Champa look like from the ground frame? So the motion of Champa from the ground frame will be nothing but the motion of Pandu plus the motion of Champa with respect to Pandu. Isn't this relative motion? Haven't you studied this? Just shift this guy over here. XC minus XP will be XCP. You have done this. X12 is X1 minus X2. V12 is V1 minus V2. VCP is VC minus VP. So XCP is XC minus XP. Will you do this? Did you understand this? Perfecto. Got it? Cool? Chalo. Now, the problem is, I don't know how to add these two. That is the problem. This is crazy. This is scary. AP sine omega t. This is one term. Second term is AC sine omega t plus phi. How do I add these two? My goodness. I don't know. It doesn't even look like a SHM. So I have a trick. I have a beautiful trick. Very good. Thank you, Vivek. I have a beautiful trick. No maths. Simple diagram. Understand this. Very easy. Phasor. Remember phasor? Acha. Let's think about phasor. Okay. Pandu's phasor. Pandu's phasor means that circular motion which represents Pandu's SHM. So if Pandu is doing this dance, okay, so he has his own phasor. I will call it AP. Okay, beautiful. Now the projection of it, either it could be on the x-axis, it could be on the y-axis, really doesn't matter. So I'm just showing, maybe this is the projection of Pandu. Okay, so this one out here, this is the projection of Pandu. Let's say this is xp. Okay, this is, let's say, xp, this one, the horizontal line. Similarly, even Champa will have her own phasor. So let's say this is the phasor of Champa. This is AC. Let's say I draw the projection, this horizontal line, that is xcp. What do I want? I want xp. I want xp plus xcp. I want xp plus xcp. That means I want this plus this, base plus base. I want base plus base. Oh my god, I am remembering the song. Baby ko base pasand hai, baby ko base pasand hai. So Champa baby ko base pasand hai. That means let's bring this xcp over here. Let's try to bring this xcp over here and see what happens. Okay, let me just draw it over here. The same thing, I'm just drawing it over here. This is AC, just drawing the projection. This is nothing but xcp. So if you think about it, I just want this length plus this length. What do I do? What do I do? I think I know what to do now. This is like a vector. This is like a vector. This is the x component. This is the x component. So I want the addition of the x components. I want the addition of the x components, my dear warriors. These two are the x components of two vectors. If I want the addition of the x components, what can I do? I just can add the two vectors. Let me just add both of them like this. This total vector, okay, whatever it is, this total vector's x component, won't it be xp plus xcp, which is exactly what you want, xc? Isn't this exactly what you want, the xc value? Got it? So what is the whole idea of whatever we did now? The idea is you had two SHMs moving in 1D. I wanted this SHM is also doing whatever it wants. This SHM is also doing whatever it wants. When you combine both these SHMs together, I got a new term. I want to find the combination of two SHMs in 1D. I found that all you need to do is draw the phasors of both the SHMs. Draw the phasor of both the SHMs and add them like vectors. Add them like vectors. The resultant vector that you get, the projection of it gives you exactly the motion that you want. You add AP bar plus AC bar, you get the resultant. So that's all you get. You get AC. Or the resultant, I can call. Okay, so that's what you get. The resultant, the component again, or the projection gives you exactly what you want. Did you guys get it? Did you guys understand it? Fair enough. So the whole idea is, if you have SHM1 x1, which is a1 sine omega t plus, let's say, phi 1. Let's say you have another SHM x2, which is a2 sine omega t plus phi 2. Let's say I want to add both these SHMs. So the resultant, what is this called? The resultant, or superimposed. Superimposed because you are combining, adding this effect on this effect, which will be x1 plus x2, can be found out by a simple method. What is that method? Vector addition of phasors. Vector addition of phasors, that's it. So you take the phasor of 1, which is, let's say, this phasor 1, A1 will be the length, phasor 2, which will be, let's say, I don't know, maybe A2, let's say. Let's probably write it over here. This is A1, this is A2, and they will have some difference between them. What will this angle be? Come on, quickly tell me, what will this angle be equal to? This will be exactly the phase difference. Okay, this will be delta phi, which will be phi 1, okay, phi 1 minus phi 2. Correct? All you need to do is just add them like vectors. Just add them like vectors. Find the resultant vector. You'll find the resultant vector, which can be also called as the resultant phasor. That's it. And then whatever this phasor angle will be there, okay, it could be some angle. So that projection will give you the final value of x1 plus x2. So this will be x1 plus x2. As simple as that. And that's it. So the final expression will be AR sine omega t plus some other phi will be there. Okay, some other phi will be there. As simple as that. Okay, is that understood, my warriors? Because this will have some other angle itself. Okay, because this had phi 1, this is phi 2, this is phi 3 maybe. That's all. So all it says is combining two SHMs of same frequency, basically omega, having your amplitudes as A1 and A2 gives a resultant which is also a SHM of amplitude. What is the new amplitude? Can you see that? Is AR, and you can get that AR by simple vector addition formula, which is A1 square plus A2 square plus 2A1 A2 cos del phi of same frequency omega. That's it. That's all you get. As simple as that. So adding two SHMs in 1D of same frequency again gives you a new SHM, okay, because the new phasor also rotates along with these phasors. It will all rotate together. It's also SHM. The new amplitude can be given by your vector addition formula, a square plus b square plus 2ab cos theta. As simple as that. Fair enough. Are you now ready to do some questions on this? Don't worry, it's all there in this theory slide as well. So I've just put this up for you, vector addition ka revision. Those of you who had forgotten vector addition formulas, I have just put this up exactly for you. Okay, great. Now how about adding two SHMs in 2D? Yep. How about adding two SHMs in 2D? You'll be like, sir, I just understood SHMs in 1D. Guys, SHMs in 2D is even more simple, actually speaking. Now, yeah, I know about Dragon Ball Z, but I have not watched it because I'm too old for it. So by the time I stopped watching cartoons, seriously, by that time, I don't think Dragon Ball Z was on television. So that's what it is. Okay, hi Khyati, hello. Melting BGM spot. Oh my god, what does it even mean? Okay, so how do you combine two SHMs in 2D? See, look at this spring. What is this spring doing? It is going up and down. It's doing SHM in y-axis. What is this spring doing? It's going left and right. SHM in x-axis. So the intersection of them, can you see the intersection of them? The intersection of them is doing a 2D motion. That's what it is. So what we want to analyze is if you combine one SHM which is going in x-axis, one SHM which is going in y-axis, then how will their combination look like? As simple as that. In this case, obviously it looks like a circle, but is it always going to be a circle? Oh well, not. It's not going to be a circle every time. I want you to analyze 4 cases. Basically, even if you analyze 2 cases, it automatically analyzes the other 2. So just imagine that there is a SHM which goes in the x-axis. So x is a sine omega t. Imagine there is another SHM which just goes in the y-axis. Okay, so that is basically let's say a2. I need to call this as a1. Amplitudes could be different. a2 sine omega t plus phi. Why this phi has come? This is the phase difference between them. The phase difference between the 2 SHMs, one is going in x, one is going in y. So let's try to understand what will happen in each case. Phase difference is 0, 90, 180, 270. I'll make you visualize this with a simple example. Okay, let's see if you can get this. Alright, so can you see I have a pandu, a teeny mini pandu out here? Can you guys see this? I don't know. Can you see this pandu, my warriors? Yeah, it's a teeny mini pandu. Okay, fair enough. Now, here we have my cell phone. Okay, so cell phone is the platform, and on this pandu, I hope you can see it. Okay, this pandu is going to go left and right, left and right. I hope you can see this. My phone is just going to go up and down, just going to go up and down. All right, so observe, pandu is just going along the x-axis, that black equation. The phone is going to go up and down, the red equation out there. Yeah. So by the way, this is a pen drive. I don't know. It's a pen drive. Can you see that? This is a beautiful pen drive I just got. Yeah. I don't know. I didn't get it on Amazon. It's a long story where I got it from. Maybe I can tell you sometime later. Okay. So what happens is, if the phase difference is 0, it means the platform is going up from the mean position. Okay. It goes to the upper extreme and then it comes down and it comes back. So phase is 0, that means the platform is going up, it's starting from the mean position, and pandu is also going towards the right, and then he will go and come back over here. So if both happen together, platform goes up, pandu goes to the right, see how it looks like. Platform goes up, pandu goes towards the right, stop, extreme position reached, platform comes back to mean, pandu also comes back to the mean, okay, and then both are at the mean, they will continue their journey towards the left and bottom. Platform goes down, pandu goes to the left, stop, left extreme reached, pandu comes back to mean, platform comes back to mean. I'll do this little bit fast. Platform goes up, pandu goes right, platform comes down, pandu comes back to mean, platform continues down, pandu goes to the left extreme, and then again come back to mean. Mean, extreme, mean, extreme, mean, extreme. How does the resultant motion look like? Come on, my warriors. How does the resultant motion look like? Okay. Okay. Oh my God. Is it unforgettable now? Oh, I'm so grateful. Thank you. Thank you, all the young warriors out there. How is the resultant motion looking like? I feel it is looking like a straight line. Isn't it? Isn't it looking like a straight line, my warriors? Observe it. It's looking like a straight line. If you are not able to visualize it, tell me. It's looking like a straight line. Perfect. Isn't it? Perfect. Everybody agrees with this? Can I go ahead? Yes. Yes. Okay. Cool. Okay. Okay. Vivek, my sessions are usually 1.5 hours. Okay. So that's what it is. Now, let's take the second example. Phase difference is 90 degrees. So for phi is equal to 0. So for phi is equal to 0, we get it as a straight line. I have put the proof for that on the screen, but yeah, it's okay. Now let's talk about the next. Phi is 90 degrees. So ignore what is there on the line. In fact, I will remove it. Okay, and see what happens when phi is 90. Phi is 90 means the platform is still trying to go up, but pandu is already at the extreme. Phase difference of 90 degrees. 90 means if one is at mean, the other is at extreme. Other is at extreme. So pandu is already at the extreme, platform is at mean. So if pandu is at extreme, he will try to come towards the mean position. He will try to come towards the mean position, but platform will go up. So if the platform goes up, pandu comes to the mean position. This is how it looks like. Platform came up, pandu is at the between. So Pandu will continue his journey towards the left, but platform will come down. Now Pandu will go to the center. Okay, Pandu will go to the center. Okay, think about it. Okay, what did I do? Okay, wait a minute. So platform goes up, platform comes down, platform comes more down, and then Pandu goes more towards the right and platform comes up. So platform at mean, Pandu at extreme. Platform at extreme, Pandu at mean. Platform at extreme, Pandu at extreme. Platform at extreme, Pandu at mean, and back over here. Observe this. Up, back, down, up, up, down, down, back. So can you see what is exactly happening out here? Just observe. 1, 2, 3, 4. 1, 2, 3, 4. What kind of motion is it? Are you able to see what kind of motion was it? I think it was a circular or elliptical kind of motion. It was more like an ellipse. Don't believe me? Observe it once more. Okay, one last chance for all of you. It's not exactly a square. It was a square because my hands are moving like that. 1, 2, 3, 4. Okay, like a PT period. 1, 2, 3, 4. So if I move it smoothly, it will be a nice ellipse. That's what it is. So observe. Once again, confirm this. Platform goes on the top, Pandu comes in the middle. Platform goes down, Pandu goes to the right. Platform comes down, Pandu goes in the middle. Platform comes back, Pandu goes here. Platform goes up, Pandu comes in the middle. Platform comes back to the mean. Platform goes to bottom extreme, and then Pandu comes back to the right extreme. Yep, can you see that now? Were you able to see that? It is like an ellipse. So for 0 degrees, it was a straight line. For 90 degrees, it was an ellipse. Perfect. And the reason why it was an ellipse is because the amplitude of vertical oscillation is not necessarily equal to the amplitude of Pandu's X oscillation. If these amplitudes in X and Y were equal, if the amplitudes in X and Y, A1 and A2 are equal, then the answer will be, come on, put it up in the chat box. What will the answer be? It will be a, come on, put it up. So then we can also think about what will happen in 180 and then 270. Now, yep, so what will the answer be? What will happen if A1 and A2 are equal? The answer will be, it will be a circle. Correct, it will be a circle. Okay, so for 180 degrees, it's very easy. You can do that very easily even by taking examples. So 180 means when platform is going up, Pandu is going towards your left instead of going to the right. So platform goes up. So one thing is going positive, other thing is going negative. So both are at the mean. Pandu goes here, platform goes up. Pandu comes back, platform goes down, and again it comes back like this. Observe. This is what the motion will be. This will be also a straight line, but the problem will be the straight line will be different. It will have a negative slope. So look at the previous one. The straight line was like this. In the 180 degrees case, it was like this. And for 270 degrees case, also it is an ellipse. So if you remember this much, it's more than enough. If you remember this much, more than enough. So for 0 and 180, it's a straight line. For 90 and 270, it is an ellipse. The last question is, what if it is not 270, it is not 90, it is not 180, it is not 0? Then what if it is some 43 degrees? What if it is some 126 degrees? Then the answer is, it is still an ellipse, but it is not a horizontal ellipse, then it is a rotated ellipse. So for all other angles, it is basically a rotated ellipse. That's all the differences. No. Okay, fair enough. You should definitely try this out with the help of, probably some instruments or maybe some doll or I don't know, any bottle cap with a book, and you will be fascinated to learn it this way. So that's what I wanted you to see. Okay, so I've put it up over here, and the simulation also you can play it again and again when the session ends. Beautiful. All right, great. So let's look at 1 or 2 questions on this. Okay, let's see if we can get this very quickly. If the displacement equation of a particle be represented by y is a sine some constant into time plus b cos some constant into time, what do you think the particle executes? Y is a sine something plus b cos something. If you combine both of them, what do you think? Is it UCM? Is it uniform elliptical motion? Is it SHM? Is it rectilinear motion? Okay. What is meant by rotated ellipse? Rotated ellipse means the axis of the ellipse are not along x and y. It's just that the axis is rotated. That's it. If it's not broadening or thinning up on x and y, it's just at some other angle. That's all. Okay. Ketan says A. Oh well, you guys are wrong about it. I think it's not. Oh, thank you for all the love, unforgettable love. Thank you so much. Yes, Shanti, it is still going to be SHM. Perfect, perfect, very good. Because this is nothing but SHM in 1D. There is no x and y. Where is x and y? There is no x and y. Both of them are two SHMs. I just gave it to you. Two SHMs in 1D. When you add them, you still get a SHM. You have to add them like vectors. Yep. Next one. The resultant of two rectangular simple harmonic motion. What is the meaning of rectangular? Rectangle 90-90. That means perpendicular. So rectangular components. Have you heard that word? Back in vectors. The rectangular components of a vector means the two perpendicular components of a vector. So that's what it means. Okay, so don't get scared by that word. Simple harmonic motion of the same frequency but different amplitudes but differing in a phase of 90 pi by 2 radians is SHM, circular, elliptical or parabolic. Come on, let's see how many of you can get this question correctly. Come on my warriors, let's see. The resultant of two rectangular SHMs of the same frequency, unequal amplitudes but different in phase by 90 degrees will be. Now this is very easy. This is two perpendicular SHMs combining in 2D. Okay, if it is 90, what was it? It was ellipse, but it will be a circle if amplitudes are equal. It's clearly mentioned unequal amplitudes, so hence it should be elliptical. Definitely Zishan, how about letting me know whatever your problems are, you know, at the end of the session. Also, I think it's a good time. We also, oh yes, I forgot that we have to also look at the homework questions before I show you the comments. Yep, so this is your first homework question. This is your first homework question, like you can see. The question is, what is the amplitude and the maximum velocity? This is your second homework question. Okay, this is your second question for homework, and this is the third homework question. Three homework questions just for all of you, and let us see who and all have done the homework out here right in this session. All right, so where is my previous session? I don't know whether you guys watch this 1 minute trick to remember anything. Please watch it, it's amazing. Okay, so oscillations lecture 2, and there we had, very good Ishpreet, let me give you a heart, Pacha. Very good Saja, very good Harita, and Susan, you are a NEET aspirant and I have helped you a lot. Thank you for loving my explanations. You get a heart out there. Thank you Chandan. Thank you Simple Girl. Very good. English paper went well. Hoping to have a great marks. Definitely. Shubham. Yes, I will definitely reply to you. And yes, very good Gokulnath. Excellent. So now with that, let me also tell you there are some very interesting links which are there right in the description box. Now some of you might want to join Vedantu for different reasons, and see, if any of these reasons that I'm giving you matches, then you should definitely consider joining Vedantu. Maybe you're not happy with the current coaching, maybe you don't have any coaching, maybe you're happy but you want to try what Vedantu is like. You just want to try. Maybe you are just happy with your coaching, it's okay. The reason why you might want to try Vedantu is probably because you don't want to travel. Number 2, you want the best teachers. You don't want to run around different centers looking out for the best teachers for physics, for chemistry, for physical, for organic. You want everyone at one single place. Number 3, you want your in-class performance. In your regular coaching, a teacher cannot assess how you are performing because there could be hundreds of students or 50, 60 students and you don't know. Everybody just probably answers together, or if a teacher asks the question, hey, what is the answer for this? Everybody shouts. You don't get to know who has actually answered, who has not. Here, there is in-class analysis. Not just that, after every test, you get a very beautiful detailed report card. It not only tells you where you stand, but it also tells you what was the average performance, where you stand in this particular topic, your topic-wise analysis, your accuracy rate, your time per question, your strike rate, so many other things which will help you improve when you compare these report cards from the previous tests. And even in the class, there are two teachers who are helping, or basically two teachers in one class. One teacher like me, the master teacher who is solving the class, who is basically teaching, and you have the class teacher who is assigned for a particular group of students just meant to solve their doubts. Just imagine, if you have any doubt, you are attending the class, you don't even have to disturb the teacher, just ask the class teacher, you get doubts get resolved. So that's what you get. So when you click on this link out here, all right, so you can see all the features are mentioned, but let me tell you, these are not the only features. There are so many other things like parent-teacher meets, and then you have these gupshup sessions, you have strategy sessions, tips and tricks, and mock tests, so many things. This is a 2-year course. You get the recordings of all the classes, you get assignments, you get notes, you get PDFs, you get doubt solving even after the class when you go for the classic version, and you can also go for personal mentorship in the plus version. Most students go for the classic version because they want doubt solving after the class, unlimited doubts. Yeah, that's what you get. But even if you want to try the light version, for 2 years it's 54,000, and even if you try it for 15 days, it's 1,350 rupees when you use my coupon code. So click over here, enter your login details, that's it. And if you want to buy the complete course, you are welcome to do so, because you get even more discounts. It's not multiplied by. Okay, you get more discounts when you go for the complete course. So try it out, and you can also pay the remaining amount even later on when you're satisfied about it. So try this out. You will not only find other teachers but also me right at your fingertips. A lot of my micro courses are there on the Vedantu platform. So try this out, and if you feel that there is some student or your friend who will need this, do recommend it. And let me tell you, the classes are in English. So that's one plus point. Okay, and remember to use this coupon code. So if you face any difficulty, you will be able to get in touch and your difficulties will be resolved. That's what you get when you use my coupon code, apart from the 10% discount. Shailaja already watches my videos on Pro. Thank you so much. VMSAT Ketan, you can give it on every Wednesday. The link is again there in the description box. So there is an assigned portion. It's all there in that link. Just click that link. You will get all the FAQs, the syllabus, the test pattern, everything is there. And accordingly, you can get your, scholarships out there. All right. So bye-bye Sudiksha, bye-bye Tushar, bye-bye Roshni, bye-bye. Take care Ketan, Cholan, Aishwarya, Zishan. Have a great time. See you. And yep, please stay safe because this new variant is out. And make sure your family and your friends, everybody is protected, and make sure that everybody around you is also vaccinated. All right, so do your bit. Thank you for loving this video, and you can follow me on my Instagram handle, that's Shreyas_Vedantu. Take care, have a great time. This was Shreyas here, your capto for this channel. Hasta la vista.